With the invention of the telephone in 1876 by Alexander Graham Bell, telegraphs moved from the mainstay of global communications to a secondary role. But it would take some time before engineers could make telephones work over great distances, such as the Atlantic Ocean.
A telegraph signal is just on or off pulses of electricity is so simple. A telephone signal is much more complex. It's a very complex electrical wave, the very complex waveform of your voice. So it requires a much greater information carrying capacity than was available in the deep-sea telegraph cables.
A telephone signal would need to be amplified in order to be discernible across long distances. By 1912, AT&T had perfected the vacuum tube, invented just 6 years prior, into a workable amplifier. As a result, by early 1915, the first transcontinental telephone line opened, connecting the east and west coasts of the United States. Unfortunately for the submarine cable industry, vacuum tubes also enabled the newly invented radio to amplify its signals great distances too.
In the 1920s, radio technology comes in, and with that, almost overnight, the cable industry takes a nosedive because the wireless technology is so much cheaper that for 90% of the time, they can carry messages instead of the cables and do it, as I say, much more cheaply.
So the first route for transatlantic telephone service was radio telephone. Again, you're using vacuum tube amplifiers to amplify the radio signal. Radio telephone service opened up between the United States and initially England and then the rest of Europe in 1927. Initially, the capacity was one call at a time. So you'd place your name in the queue, and when you got to the head of the line, the operator would call you and say, "It's your turn."
However, wireless telephone service soon proved itself to be unreliable. With radio, callers are at the mercy of the atmosphere and weather conditions, which are neither simple nor stable. A more reliable means of transatlantic telephone communications was needed. Once again, business looked to the submarine cable. It wasn't until the early 1950s that the vacuum tube amplifier had been perfected for deep-sea use. In 1955, America's AT&T and the British Post Office began laying the first amplified telephone cable onto the floor of the Atlantic Ocean. Early transatlantic telephone communications required two cables across the ocean. One handled the west to east portion of the conversation, the other handled the east to west portion. It would take 2 years to lay the cable, a year for each direction. Thanks to the experience gained from past submarine cable ventures dating back to the days of Cyrus Field, most of the kinks and problems laying wire into the depths of the Atlantic were now solved. It was smooth sailing for 2 summers. On August 14, 1956, 90 years and 18 days after the Great Eastern had landed the end of the first successful telegraph cable in the same waters, workers made the final splice in the telephone cable known as TAT-1, Transatlantic Telephone Cable 1. On September 25, 1956, the chairman of the board of AT&T, Mr. Cleo Craig, picked up the phone and called Her Majesty's Postmaster General, Dr. Charles Hill, on the other side of the Atlantic Ocean.
This is Dr. Hill in London. Is that you, Mr. Craig?
This is Mr. Craig.
Well, it's very good to hear your voice and to join with you and our friends in Canada in inaugurating the first transatlantic telephone cable service.
Within a few hours, one of the 20th century's greatest technical achievements passed quietly into everyday use.
After the success of TAT-1 in 1956, cables were laid not just across the Atlantic, but in almost every other direction. And in the years After that, cables have been laid connecting every continent on Earth.
By the mid-1970s, copper cables, which carry electrical impulses in waves, began to be replaced by fiber optic wires. These cables use extremely fine, flexible glass or plastic fibers, which transmit light pulses instead of electricity. With modern fiber optic technology, great distances for submarine cables are no longer an obstacle. On June 17, 1997, a cable project named FLAG, Fiber Optic Link Around the Globe, was completed. This $1.2 billion cable lies at the bottom of 12 different oceans, crosses 3 continents, touches 12 countries, and is able to carry 600,000 simultaneous telephone calls per section. This cable touches 75% of the world's population.
The FLAG cable is the longest submarine cable that has been built to date. It is a 28,000 kilometers system that extends from Port Curno in the UK to Miura at the south end of Tokyo Bay in Japan. This cable provides considerably more bandwidth than has been provided in this same region, and it provides a synchronous, low error rate performance. Better by far than satellites.
In addition to being extremely expensive, a satellite call must travel 27,000 miles from Earth to the satellite and then another 27,000 miles back. A transatlantic cable call need only travel about 2,500 miles point to point. At the speed of light, this helps eliminate the annoying delays and echoes of a satellite telephone call.
Furthermore, there's a problem of the security. The satellite signals are broadcast, anybody can pick them up, whereas the cable is a point-to-point secure system.
Thanks to fiber optic submarine cables such as FLAG, many countries have an affordable, reliable means of communicating outside their country. Finally, virtually all parts of our world are connected. We can now fax a note around the world, watch our favorite movie on television, speak to someone 3,000 miles away, and download something off the internet, all simultaneously through one cable. There will be no limits on global communications, all because of the ability to sync cables to our ocean's floors.
I think I'm a relatively young man, right? But when I started, I made telegraph cable. And now I'm involved in projects where we're talking about cables with capacities of 5 million telephone circuits on a simple cable, less than 1 inch diameter, lying on the seabed. And this across any of the oceans of the world. It is impossible to see the full size of the market, but it obviously is going to be huge beyond the cognition of anybody, huge beyond our imagination.